Assalamualaikum and have a nice day. I wish to our beloved lecturer, Sir Haji Mukhtar Awang. Today, we will be presenting about our topic, which is Industrial Revolution 4.0. I hope you will enjoy this presentation. First of all, I will introduce to you our group members, consist of me, Arif Izlan, Amir Naqib, Ahmad Bukhari, Aiman Syafiq, Ahmad Syafie, and Fahmi Hakim. I will start this presentation with history of Industrial Revolution 4.0. From the year 1784 until now, there have been 4 stages in the ongoing process known as Industrial Revolution or IR. The first IR, which is mechanical production based on water and steam, occurred at the end of the 18th century. The second IR occurred at the beginning of the 20th century during the introduction of conveyor belt and mass production, and is related with the name of icons such as Henry Ford and Frederick Taylor. The third IR occurred in the digital automation of production by the usage of electronic and IT systems. Industrial robots, which are a key driver in IR 4.0, have evolved significantly at the beginning of the 21st century. The phenomena of IR 4.0 was mentioned in German for the first time in 2011 during the Hannover Fair event in Germany as a suggestion for the development of a new concept of German economic policy based on high technology strategies. Today, modern manufacturing plays an important role, particularly in European countries. IR 4.0 is defined by a high level of complexity and the usage of full network integration of product and manufacturing process. That's all from me. I will pass to Fahmi Hakim for the next slide.
Thank you, Arif. Assalamualaikum and have a nice day. My name is Fahmi Hakim and I'm going to give a presentation on what Industrial Revolution 4.0 is and how it differs from Industrial Revolution 3.0. First, let's have a look at the term. The term Industrial Revolution 4.0 describes a new phase of the Industrial Revolution that focuses on the interconnectivity, automation, machine learning, and the real-time data. Industry 4.0, also known as the Industrial Internet of Things, IIoT, or smart manufacturing, combines physical manufacturing and operations with smart digital technology, machine learning, and big data to create a more holistic and connected ecosystem for manufacturing and supply chain management companies. Okay, next, I will discuss the difference between IR 3.0 and 4.0. In Industry 3.0, we automate process using logic processes and information technology. This process often operates largely without human interference, but there is still a human aspect behind it. Where Industry 4.0 comes in is with the availability and use of vast quantities of data on the production floor. For an example of the old way Industry 3.0, take a CNC machine. While largely automated, it still needs inputs from a human controller. The process is automated based on human input, not by data. Under Industry 4.0, that same CNC machine will not only be able to follow set programming parameters, but also use data to streamline production processes. Basically, third industrial revolution consists of IT and computer technology are used to automate process, and the fourth industrial revolution includes enhancing automation and connectivity with CPS. To put in simple words, the basic difference being that the machine works autonomously without the intervention of a human in Industry 4.0, whereas in the Industry 3.0, the machines are only automatized. That's all from me. Next, I will pass to the next presenter.
Thank you, Fahmi. Now I would like to explain about the components of Industry 4.0. There are 4 core components of Industry 4.0. The first is cyber physical systems. Cyber physical system is aiming to integrate cyber and physical production processes. In other words, at various levels, computers and networks should monitor physical manufacturing processes. There are 3 stages to the development of such high-tech systems. The first is identification. Identification is critical in the manufacturing industry, as each machine and process must be identified separately. And the second is sensor and actuator integration, aids in the control of machine movements and the detection of changes in the environment by working machines. Their utility is limited, however, because they do not allow machines to communicate with one another. The third is development of sensors and actuators allow industrial equipment to interpret and store data. As a result, cyber physical systems increasingly include many actuators and sensors that may be networked to facilitate data transmission. Second is the Internet on Things. Machines have been able to communicate data and sense changes in the environment for years. Fire alarm are a good example. As a result, the Internet of Things is widely regarded as Industry 4.0 most important component. In this way, the Internet of Things facilitates the collaboration of cyber-physical systems by using unique addressing schemas. And the third is the Internet of Services. Most electronic equipment is now connected to the internet or a smartphone thanks to technological improvements. Their utility, however, is restricted by the difficulties that arise from the wide range of smart gadgets and electronics. The Internet of Services aims to create a relationship between all connected smart devices in order to get the most out of them by making the integration process easier. And the last is Smart Factory. A CAM system is used in smart factories to deal with both physical and virtual systems. CAM systems are sometimes known as background systems since they work in the background. They are, however, mindful of the item and surroundings around them and can be provided information about the products being created at a given time. Industry 4.0 seeks to transform the manufacturing and engineering industries by developing factories where cyber processing systems connect via the Internet of Things, supporting humans and machines in completing tasks in the quickest time possible. That's all for me. I will pass the presentation to Syafie.
Thank you, Syafie. Now I will continue with the emerging Industry 4.0 technologies. First is Big Data and Analytics. It refers to the large amount of data which comprises of both structured and unstructured data. Abundant amount of data with human effort as the real value of those data cannot be derived. Insight that can enhance the decision making are the result of the current computing capabilities. Second is autonomous robots. They are self-sufficient machines that can manage their tasks intelligently without the need for a human operator. Its usage can quickly and accurately perform repetitive tasks which they are programmed for. Besides, they only require little to no downtime except for maintenance. Third is digital twins. It is a virtual version of a real-world physical asset or system that is constantly updated. It is a true-to-reality simulation of the physics and materials of the real-world physical asset or system. It also includes a virtual representation of computer networking architecture. Fourth is horizontal and vertical system integration. Horizontal system integration is envisioned as connected network of cyber physical and enterprise systems that introduce exceptional level of automation, flexibility, and operational efficiency into production process, while vertical system integration is aimed to connect all logical layers within the organization from the field layer up through research and development and others. For the fifth is Industrial Internet of Things, IIoT. IIoT refers to the usage of small sensors that enhance the manufacturing and industrial processes by collecting and monitor data in real time throughout businesses. It transforms the data in the industrial environment using smart machine and real-time analytics. Next is cybersecurity technology. It refers to the practice of defending digital systems such as computer, server, network, and data from malicious attacks which can occur in internet and external form. It is a serious issue. Among top cybersecurity technologies nowadays are artificial intelligence and deep learning. Next is the cloud. It refers to offsite storage which is maintained by a third party. It uses a remote database to secure and safely save the business data. Cloud storage is the clear champion over hard drive storage as it is safe, is data sharing, and cost effective. Next is additive manufacturing. It refers to computer control process that deposit layers of material to create 3D object. It differs with traditional manufacturing as precise shape. In additive manufacturing ensure no waste, while traditional manufacturing requires machining or other techniques to remove surplus material. In addition, there is artificial intelligence and machine learning. Artificial intelligence refers to the ability of a digital computer or computer control machine to perform tasks commonly performed by human beings, while machine learning refers to a data analysis method that automates analytical model building. Machine learning can learn from data, identify patterns, and reach conclusions with minimal human intervention. Lastly is augmented reality. It is an enhanced version of the real physical world. It is achieved using digital visual elements, sound, and other sensory stimuli which delivered through technology. An example of augmented reality is Google Glass. That's all from me. Now I will pass this presentation to Ahmad Bukhari.
Thank you, Muhammad Shafi'i. Hi, I am Ahmad Bukhari. We'll proceed with IR4 benefits to audit profession. First of all, now auditors are able to analyze large data sets. The existence of technologies in IR4 such as artificial intelligence, big data, and machine learning assists auditors to to perform better as they have the ability to gather numerous information from sources other than accounting records. More audit evidence can now be obtained, which then can be used to identify risk indicators or misstatements that would have gone undetected if only financial data was examined. Next, improvement in accuracy are obtained where automated tasks performed by robots not only make the audit more efficient, but they also have the potential to produce results that are as reliable as manual processes when combined with auditors' review. Furthermore, with IR4 technologies, auditors able to focus on high-risk areas rather than performing mundane tasks, as they help auditors to spend more time on the audit, applying their thoughts to more complicated, subjective aspects of the audit, since routine and repetitive duties can now be automated. Hence, this benefit leads to another benefit, which is fraud detection, because big data analytics may make fraud detection more effective, as both financial and non-financial data can be analyzed with ease. Now let's move to IR4's possible threats to audit profession. First, reliability, compatibility, and security of data inputs may be at stake, as AI necessitates a large amount of high-quality data. However, external big data is unreliable due to the limited field stored, making it difficult to verify its origin, even though external audit evidence is generally considered to be more reliable than audit evidence generated internally. Hence, AI's performance is constrained by a lack of data or data of poor quality. Secondly, auditors may over-rely on the technologies but with a low level of understanding and skills how the technologies work. Auditors who lack in both appear to be a huge barrier to audit firms that implementing IR4 technologies in their audit process. In a worst-case scenario, for instance, when using AI, algorithms may identify false or misleading correlations in data, and it may cause financial and reputational harm to users of financial statements, such as investors, if the auditors make inappropriate decisions based on biased algorithms. Lastly, cost of adoption may create a barrier between giant and small-sized audit firms, as the emerging technologies require huge investment, both financial and non-financial, which giant audit firms have the ability to consider the technology's adoption to serve their clients. Meanwhile, small audit firms will strive to remain competitive in the industry. That's all from me. I'll pass this presentation to Amir Naqib. Thank you.
Thank you, Bukhari. So now I will proceed with the impact of audit profession in Industrial Revolution 4.0, or IR 4.0 in short. As for always on learning experience, individuals must continually learn and adapt to the current environment because of the rapid pace of technological change. As a result, the rate at which people learn is speeding up and abilities are becoming obsolete at a faster rate than in the past. Auditors today are in similar scenario, needing to reskill and upskill a regular basis to be relevant. To meet the demands of the changing workforce, multi-skilled employees are in high demand. Next is agility. The capacity of auditors to immediately comprehend and respect the client's business as part of the audit process is critical for a successful audit. Agility in particular will be highly appreciated as the business models evolve and existing ones shift more frequently. The maturation of thought process will be aided by relevant experience and exposure in a dynamic environment. Furthermore, the auditor's ability to rethink, rejuvenate, and even reinvent themselves will help to an audit firm's long-term viability in changing environment. Moving to adaptability, although the core abilities will continue to be vital, the growth of staff in an audit company is no longer solely dependent on the traditional audit skill set. Careers can now progress in any direction. They are no longer limited to up or out. Adaptable people can assist. Talent movement will be high demand. These are people who are open to others' people's ideas, are not bound by certain point of view, who are often trained to seize opportunities, and who are resourceful in achieving personal and organization goals. The value proportion for these employees is such that the new abilities to get to be useful in fields other than auditing and accounting. The skills will be adaptive and transferable, making them more marketable and relevant. This may appear odd, given that these employees may be targeted by organizations both inside and outside the industry. However, a larger viewpoint should be taken so that even if employees do not stay in the organization or audit profession for their whole careers, they can become ambassadors for the profession by demonstrating the values that serve to distinguish them from other professions. not to forget data vigilance. Improvement in technology brings with more automation and better data analytics too. In audit profession, the use of data analytics in performing audit and to provide more value added to the clients are becoming more common. With the availability of relevant data and the right tools, data analytics can provide better visibility of trends and highlight exceptions in more efficient manner. And the last one is network of teams. The ability to work in group will be important in the future. The team's dynamic, on the other hand, will change the time and vary terms of background diversity, geographical location, team size, abilities, and competences. As more professional firm networks begin to operate with diverse business models such as shared service centers, audit delivery centers, cross-border business operation, and cross-business line collaboration, audit teams will functions vary. Effective teamwork in the IR 4.0 will require effective collaboration and communication in a virtual setting to get the job done on time. With the team dispersed throughout the globe, in the future, structural hierarchies are expected to be replaced by networks of teams with authority to act. That's all from us. Thank you.